Hello guys, welcome back to my channel. In this video, we are going to talk about prisms and volumes. Well, prisms are a group of 3D shapes, and the other group of 3D shapes are pyramids. For now, we are going to talk about a prism, especially a cuboid in this particular question. Okay, here they say the volume V and the base area of a cuboid are given in the diagram. Here's the cuboid, which is also called a rectangular prism. We have this rectangular face at the front, which is shaded, and the area is given. It's 44 square centimeters. And the volume of the whole shape is 264 cubic centimeters. And this is the length, L. And the question is, what is the length in meters? What's the value of the length in meters? So take note, after we find the length in centimeters, because the area and the volume are given in centimeters, the length that we'll find will be in centimeters. After we do that, we have to change to meters. All right, before we get into it, this is the general formula to find the volume of a prism, any kind of prism, whether it's a cuboid, rectangular prism, or a triangular base prism, or a circular base prism. The formula is the same. The volume is equals to the area of a cross section times the length. The cross section can also be called a base depending on the shape, the 3D shape, and how it is oriented, meaning how it is drawn. Okay, the length is the distance between two opposite end cross sections. I'll show you what that means. So here's our prism, which is a rectangular prism. They already shaded the cross section and they gave the area already, which is 44 square centimeters. All right, cross sections first. A cross section is an identical shape you will get when you cut the object along a particular line from one end of the object to the other end. For example, if we are going to cut this cuboid up from the top down, from the front all the way to the back, we'll get this front rectangle, and as we cut towards the back, we'll get exactly same rectangles as the one in front all the way to the back part, and we call them cross sections because they are exactly the same. And the length is the distance between the front cross section and the back cross section, which covers the whole 3D shape. Okay, take note, for this cuboid, it has three pairs of cross sections. What I mean by that is you can cut the prism from the top down and you will get a front rectangle which is exactly the same as the rectangle at the back. So we have these two, the front rectangle and the back rectangle make up one pair of cross sections. So the length will be the distance between the front rectangle and the back rectangle. We also have a rectangle on the right side which exactly matches the rectangle on the left side. So like if we cut this rectangle down along this line, cut it this way, down, then we'll have this rectangle exactly matching that rectangle. So the length, well, those two are the cross sections, that's the second pair, and the length will be the distance between the right side rectangle and the left side rectangle. That's how we find the volume. Or we can slice it, like we peel it from the top down and we cut along this horizontal line. We go top rectangle all the way to the bottom rectangle, which are exactly the same. So that's the third pair of cross sections. Now the length will be the distance between the rectangle at the top and the rectangle at the bottom, which is this distance. Okay, so to find the volume of a prism, any prism in general, we go area of the cross section times the length, which is the distance between the two cross sections. And take note, the cross sections must be in opposite positions on the shape. If one is at the top, then the other one must be at the bottom, top and bottom, front and back, left and right. So the length is the distance joining those two cross sections. Okay, let's get into the calculation part. So here we have the volume is equals to length times width times height. Well, length times width is the area formula of a rectangle, and this gives the area of the cross section. And times height for our shape here, since the prism is lying flat on the ground, the distance between the two cross section is length because it's lying flat on the ground instead of height if it's standing up. So the height now becomes the length, and we substitute since the volume is 264 cm cubed and the area is 44 cm squared. We substitute into the formula. Volume is 264, area is 44 times the length. And in order to find the length, we have to divide by 44 on both sides. And take note, when you are moving things to left and right side of the equal sign, take note that left is the opposite of right. So if you are moving left and right, you gotta carry out opposite operations. Since we have multiplication already here, the opposite of multiplication is divide. And so we divide by 44 on both sides, giving L as 6 centimeters. Now the question says to change the length to meters, find the length in meters, and so we have to change the centimeters to meters. And to do that, we have to change centimeter to meter. That's a small unit to a big unit, and we have to divide. We'll divide by how many centimeters are in a meter. Well, there's 100 centimeters in a meter, and so we divide by 100. And when we divide by hundreds or tens or thousands, we move the decimal point to the left, and we move it according to the number of zeros. Since we have 2 zeros, we move it 2 steps. 1, 2. And so our answer in meters is 0.06 meters. Okay, checking our options. They are 3, 4, 5, 6. Nothing of 0.06. And so this question doesn't have any answer. Looks like they gave the answers in centimeters, which is not according to the question. The question says to give the length in meters. So this question doesn't have an answer. Now, I would like to show you another way, which I call the Thomas way. And the name Thomas comes from the Thomas in the Bible who did not believe that Jesus was Jesus, and he needed proof. That's the whole idea, proof. So we are going to be like Thomas, and we are going to check all the options that are given, A to D. And this Thomas method is applicable When you have an equation like this where you have one side is known and the other side you have an unknown, so you can simply substitute the options in place of the unknown and then you check which one works, which means which one makes the left hand side equal same to the right hand side. Okay, so let's start. First option, A is 3. Our equation is the volume 264 is equals to 44 times the length, area of the cross section times the length. Let's check if the length is 3. If it is 3, then 44 times 3 is 132. 132. Let me just confirm with the calculator in case my brain is not braining properly. Oopsie. Okay. 44 times 3. 44 times 3 gives 132. Okay. Since it does not give us 264, meaning the left side is not equal to the right side, then this is not the answer. Let's check option 2. Option 2 says the length is 4. Let's substitute. 44 times 4 gives 176. 44 times 4. 176. Okay. Well, it's not the volume, not the correct volume, so it doesn't work. That's not the answer. Next option, C, 5. So we check. 44 times 5 is 220. Doesn't work, which leaves us with the only option, which is D, 6. Let's pretend that the instruction doesn't tell us to change the length to meters, so we'll agree with the answers provided just for the sake of using this Thomas method. And okay, the only option left is D, which is 6. And to confirm 100%, let's go and substitute. So 44 times 6 is 264. Let me confirm again. We are Thomas, so if you have to, you gotta prove and prove and prove. Check. The volume is 264 right there. That means D is the answer. Take note, we are pretending that the question is asking us to give the answer in centimeter. Okay. Now, since we are talking about prisms and volumes, let's also go and view some other prisms which are not cuboids in nature. And here they are. We have a cube which has cube cross sections everywhere, front and back, right and left, top and bottom. The formula for the volume is the same. Area of the cross section, and take note, cross sections are exactly same shapes in opposite positions, opposite ends of the 3D shape. So if you choose the one in front, then the other cross section is at the back. So the length is the distance between the front square and the back square. If you choose the right side, then the length is the distance between the right side square and the left side square. Then we have a cuboid, which we just looked at, and then we have a cylinder based on the name cylinder from circle. So the cross section is a circle. One at the, it depends on how the shape is oriented. If it's lying down, then one on the left side and one on the right side. Circles exactly the same. If the shape is standing up, then one is at the bottom and one is at the top. Exactly same shape. Those are your cross sections. You can experiment by cutting. If you cut along this line, you'll find that you have rectangles with a smaller at the first, and then in the middle you'll have a bigger rectangle, and then you go smaller rectangles again. But if you cut down this way, you'll see circles all the way. So circles are your cross sections. That means the length is the distance between the two circles on the two opposite ends of the shape. Now let's look at the triangular prism, and as the name says, see, the cross sections are triangles. And of course, you have to know the formula for the area of those different cross sections. For a circle, it's pi r squared. And pi r squared is the area for the cross section, which is the circle, and then L is the length. H is the height if it's standing up. For the triangular prism, a triangle is the cross section, so you identify those triangles. One is this side and one is that side, opposite sides. So the length is the distance between those two cross sections. Therefore, the volume is area of a triangle, half base times height times the length, which is the distance between the two triangular cross sections. And then we have a trapezoidal prism. Based on the name, the cross sections are trapeziums. Exactly same shapes. So the length is the distance between those two trapeziums, and you must know the area formula of a trapezium, which is half plus a plus b times the height. AB are the two parallel sides on the trapezium, which is that side and this side. They go in the same direction. The lines go in the same directions, parallel. And the height is the distance between those two parallel lines, and it must be perpendicular, which means it must form a 90-degree angle with the two parallel lines. So AB over 2, or half AB times the height, is the area for the cross section. Now to get the volume, you have to multiply by the length, which is the distance between the two cross sections. All right, I want you to put the video on pause and you try out this question, which is taken from 2000 exam booklet. It says here, the diagram shows 5 solids not drawn to scale, meaning they are not measured and drawn, they are just drawn and then the measurements are written on them. They are all in centimeters, the measurements are all in centimeters. Which solid has the greatest volume? That means you have to calculate the volume of all 5 shapes, then you compare them and see which one is the biggest volume. Okay, I hope you have tried that question, and here are the answers. Well, the first shape is a cuboid, so it's just length times breadth, or length times width, which is the area for the cross section, times the breadth, which is the distance between the two cross sections, and you substitute the values in, you should get 1800 cubic centimeters. The second shape is a cylinder with a circular cross section, so the circle is pi r squared, area for a circle is pi r squared, times the height, which is the distance between the two circles. So pi 3.14 times 6 squared times 15 gives this 1620 cubic centimeters. Then shape C is another rectangular prism or cuboid. So we go length times height times breadth. It depends on how the shape is oriented. So 5 times 12 times 20 gives 1200 cubic centimeters. The next shape, shape D, is again a cylinder right here. The diameter is 20, so the radius is 10. The area of a circle is pi r squared. Pi is 3.14, the radius is 10, which is half of the diameter, squared times 8, and you should get 2,400 cubic centimeters. And the last one is a triangular prism. So the cross sections are triangles, and area of a triangle is half base times height, half of 5 times 20 times the distance between the two cross sections, 40. There it is, half times base times height times the length, half times 5 times 20. Well, half of 20 is 10, and 10 times 5 is 50, and 50 times 40 is 2,000. And by comparing all these volumes together, you would have found that the greatest volume is 2,400 cubic centimeters, which come from shape D, which is this cylinder, short and wide. This one is from the 2022 paper, and it's about the cylinder. The cylinder below has a diameter of 14. Diameter is the distance from one part of the circumference through the center of the circle to the other part of the circumference. It's 14. And the height of 21 centimeter. Its curved surface area, A, shown on the right, is given by A equals 2 pi r h. This is the curved surface. Actually, this is the curved surface, which is flattened out and which looks like a rectangle. And this is the net of the full cylinder. If you open it up and flatten it out, you have a rectangle connected to two circles. And they say, what is the area of its curved surface, which is basically this part. Now, if you look at it, this looks like a rectangle. Why are they saying the area of this rectangle, which when rolled up makes up the curved part of the cylinder? Why are they saying that the area is 2 pi r h? Well, this is a rectangular piece of paper right here. Now you see, if we roll it up, it will create a cylinder. You see, it's a cylinder with one end is a circle. Not mine is not perfect, but I hope you get the idea. One part is a circle, the other part is a circle. So these two circles are your cross sections, and this part between the two circles is the length. And so instead of saying length times width, keep that in mind, length times width. When we roll it up, the width now becomes the distance between the cross sections, which is the height if it's standing up, and the length becomes the circumference of the circle at the top end and the bottom end. Look at the circle and watch as I unroll it, and you'll see it becomes the length. It becomes the length of the rectangle. When I roll it up again, it becomes the circumference. It becomes the circumference of the circle. Okay. And so instead of length times width, they say 2 pi r, which is the formula for the circumference of a circle, times the height. So instead of length times width, they go 2 pi r for the circumference times the height, which is the distance between the two circles. Okay, so let's answer the question. What is the area of its curved surface? And this is easy. We'll just have to substitute into the formula. A equals 2 pi r h. A equals 2 pi RH. Let's just substitute 2 times pi. They say pi must be 22 over 7, and the radius is half of the diameter, and the height is 21. So we cross these two sevens, and now we have 2 times 22 times 21. 2 times 22 is 44, and 44 times 21. 44 times 21 is 44 times 20 plus 1. 44 times 20 is 880. 44 times 1 is 44. 4 plus 0 is 4, and 4 plus 8 is 12. So write down 2, carry 1, and 8 plus 1 is 9. So the answer is 924 centimeters squared. Checking out the options given, well, our answer is B, 924. If they do not write the unit cm squared on the answer sheet, please, you must write the unit yourself. Okay, that brings us to the end of prisms and volumes. Please don't forget to subscribe to my channel, and see you in the next video. Take note, I will upload a lot of videos before the exam. So stay tuned. And again, like and subscribe, and see you in the next one. Bye.